Hello everyone, this is Brad Wood, and I'm going to show you today task runner lifecycle events. So CommandBox task runners are amazing, and they allow you to run cold fusion code, arbitrary cold fusion code from the command line with no running web server and no web browser anywhere to be seen. The anatomy of the task runner I've covered in other videos, but basically it is a CFC, usually called task.cfc by default. You can have whatever methods you want by default. We'll look for a method called run, and we'll execute the code in that method. So here I have a task.cfc. It has a run method, or a target as we call them, and then one that I created called build, that just outputs the text ran build. So if I go to the command line, I'm sitting here in a folder where my task.cfc lives. I can run task run and run my default target, or I can say task run target equals build, and I can run my build target. Simple enough. So CommandBox task runners also have a bunch of lifecycle events that you can have run automatically inside of your task, and this is basically the full list here. So let's break them down. There's pre-task, post-task, and around task. So these are for any code that you want to run before, after, or sandwiching around any of the target methods inside the task. And so just to give us a look at what this looks like, and create function, oops, gotta spell it right. Function pre-task, and we can say before task. And all of our events get the name of the target being run, as well as the arguments being passed to it. All right, let's see if these are passed. It's named parameters. Okay, so before task, target. Actually, I should say before target. There we go, before target run, and if I run my build, before target build. And so likewise, the next one was post task. So if I create a method called post task, basically if the methods exist, they are automatically picked up and run. All right, so I have a pre-task and a post-task, and if I run, we have before our target build, we ran the build, and after our target build, right? And then, I don't necessarily have to demo all these, but the around task is a little bit special in that it looks like this. So the around task allows us to wrap any kind of functionality around the actual UDF that is the target that we're running. And so we'll say print line, first half of a round task, all right? And then the second half. So if I wanted to wrap a transaction or a try catch around the actual target being run, I could do this. So let's indent these a little bit. And see what our output looks like now. Looking for my second half. Oh, that would be because I have a return statement there. If you are returning a value from your target, you'll need to make sure you capture the output of this or return it. In this case, I'm not returning anything. I'm just printing stuff. So I'm just going to get rid of that return. And then let's also adjust our spacing a little bit. All right, let's try that again. There we go. So first half of our around task runs, then our before target runs, then our actual target, then our after target, then the second half of our around task. So they nest together like that. So those are the first three lifecycle functions. And these apply to all of the targets in the entire CFC. So if I change this, instead of running the build target to run a default target, everything still runs, right? We also have a pre-target name, post-target name, and around target name that do exactly what you assume they probably do, except for they are specific to the target they're named after. So I'll copy and paste these, and I'm going to call this pre-run, post-run, and around run. So these are only going to apply when I'm running the run target. Okay, so just hard change these messages real quick so we can tell what's going on. First half of around run, second half of around run, and I think I want to indent each of these in. Okay, it's getting fun, isn't it? So when we run build, it's the same as before because my new methods only apply to the run target. So now I'll do a little default task run. Woo! So now the first half of our round task ran, and our before our pre-task, then first half of our round run, then before our target run, then our actual target ran, then our after target run, the second half of our round run, our after target, second half of a round task. You get the picture. You're probably not going to use all of these at the same time, but this is how they nest together. Okay, let's simplify a bit and go back to some more likely ones. So we have on complete and on success. The difference is on complete fires every time, regardless of whether the task was an error or not. On success only fires if the task was actually successful. So let's get rid of all these pre and post and around dudes just for a minute. Simplify it back to a much simpler example. So let's give ourselves an on complete. Says print line. We're done here. Okay. I guess I shouldn't mix my my quotes, should I? All right, so on complete will fire every time. And then our other one was on success. This will output a green line because it's successful. And say, woo. Yay, it worked. And then we also have an on fail, which fires if the exit code is failing. And we also have an on error. On fail and on error are very similar. The only difference is it's possible to have a task that fails without technically raising an unhandled exception. So for instance, if we have set exit code, right, and we set the exit code to 5, this task will be failing, but not necessarily erroring. But if I actually throw an exception, right, then this task will be both failing and erroring. So only erroring actually has an exception object like you would get with a try catch. So I'm going to change my my build to actually fail via an error. So this will be failing and erroring. And so it doesn't really matter which one of these. Well, I'll use on error because that one is a little bit different in that it receives an exception object specifically, whereas on fail just gets the status code. So we will have, let me just copy and paste, have an on error method. This will output a red line. Woo. It says no. It broke. And let's see, how do we access that exception object? All right, on error receives additional data, exception. So we should also be able to say it broke with message exception.message. Let's see if that works. This should be interesting. So, task run, our default target ran, our on success runs, yay, it worked, and our on complete ran. We're done here. Okay? And if I run the build target, then it blows up. So our target ran, our on error ran. Oh no, it broke with message. Boom, which was the message we passed into our throw. And then our on complete still runs because the task always completes, right? We're done here. And then our actual exception is thrown. And of course, you'll notice our on success did not fire because this task was, well, not successful. Okay, there's a couple more. There's also an on cancel, which can be kind of convenient, specifically if you interrupt a task with the Control C. So in my run, if I say sleep for 10 seconds, then whenever I run this task, it'll sleep for 10 seconds. So if I hit Control C, it's going to cancel. So we our on complete still runs when we canceled. So if we change on complete now to say on cancel, okay, and we output we gave up. Make this yellow. Sad, sad yellow color. I can run it, hit Control C to interrupt that sleep, and our on cancel runs that says we gave up. So there you go. Basically, you can tap into any kind of before, after, during, around kind of stuff. You know, did it complete at all? Was it successful? Did it fail? Did it specifically have an exception that was thrown? Was it canceled? And then you have access to all sorts of information as to the target that was running, the exception that happened. You can control exactly how the UDFs are invoked. You can even override things like the arguments via these task args that are passed in, so you can change arguments on the fly. And then for every single one of those, there is an only and an except, basically a whitelist and a blacklist, where you can specify only the targets that you want to be applied. So you can have an on cancel method, and then at the top of your CFC, come on, copy to clipboard and go. All right, only going to copy part of it. We'll make that work. So at the top of my CFC, I can set this dot on cancel only is run or build and another method, right? So we can even narrow down when these lifecycle events fire if you don't want them to apply to everything in the CFC. Or if you want to exclude just a couple methods and you want it to apply to everything else. So there's a lot of ways to use those. Obviously, you're probably not going to be using, more than a handful of these. But if you have, a task CFC being used as a build, you've got a handful of targets in there that you're using for, various different things. And you have some logic you just always want to run when it's done or when it fails. I mean, this could be sending emails. This could be writing out log files. It could be zipping up stuff. It could be deleting, temp files. You can basically use, things like your on complete as sort of an effective, like, finally block. No matter what happens in this task, even if stuff, blows to heck, your on complete's always going to run, and you can use that to clean up temporary files off the disk or things like that. So lifecycle events are super useful, and all you have to do is just define them, and they will automatically get run at the appropriate time. So that is all, and have fun tasking.